This video is on conic linear systems. Systems of equations just involve two or more equations being graphed on the same set of axes, and the solution to a system of equations is a point of intersection. So for a conic linear system, that means we have a circle and we have a line. So there are three possibilities. On the left, you see that the line and the circle will never intersect. Therefore, there's no solution. In the middle, you see one where it is tangent to, the line is tangent to the circle, meaning there's one point of intersection and therefore one solution. On the right, we have a line that goes straight through the circle, so there are 2 points of intersection and therefore there would be 2 solutions. So if we take a look at a question that's multiple choice, it says the graphs of the equations x squared plus y squared equals 4 and y equals x are drawn on the same set of axes. What is the total number of points of intersection? They don't want to know the actual points, they just want to know how many of them are there. So x squared plus y squared equals 4 is the equation of our circle. So for this question, we're just going to sketch a quick picture. The center of my circle is 0, 0 because there's nothing being added or subtracted to the x or to the y. The radius of my circle is going to be 2 because it's the square root of 4. So I'm going to sketch out a picture. It doesn't have to be perfect. Remember, we just want to have an idea of how many times is it going to intersect. So here's my circle. Now, y equals x is our line. So for this, you have two options. You can go to your calculator and look at the picture or the table, or you can use the slope and y-intercept. So if I go to my calculator, I can go to y equals, clear out anything I have there, and I'm just going to put in x because my equation is y equals x. If I take a look at my graph, it's a straight line that runs straight through the origin. So it's going to look something like this on my graph. And I have 2 points of intersection. So that's my answer. Let's look at another question. This time, you're being asked to solve algebraically. So I need to solve for the system, which means I need an x comma y as my answer. So the first thing I want to do is I'm going to take my linear equation, x plus y equals 1, and I'm going to solve it for either an x equals or a y equals. I'm going to subtract x from both sides. So I'm going to get y equals 1 minus x. Now what I'm going to do is I'm going to substitute that into my circle. So x squared plus y squared equals 61. I'm going to take this 1 minus x and plug it in for y. So I'm going to get x squared plus, instead of y squared, it's 1 minus x squared equals 61. So for that 1 minus x squared, you need to either double distribute or use the box method. So I'll show that over here on the side, just so we have that. 1 minus x times 1 minus x. So I end up with x squared minus 2x plus 1. So I have x squared plus my answer from my box method, x squared minus 2x plus 1 equals 61. On the left side, I can combine like terms. 2x squared minus 2x plus 1 equals 61. Now, I want to set it equal to 0 because whenever I see an x squared, I know I have to have it equal to 0. So I'm going to subtract 61 from both sides and get 2x squared minus 2x minus 60 equals 0. My next step is to factor. If I look, I have a GCF. All three of those terms can be divided by 2. So I'm going to factor out a 2. And then I'm left with x squared minus x minus 30 equals 0. I can continue factoring from here, 2 parentheses, x, a negative, and a positive. My factors of 30 I'm going to list out on the side to make it a little bit easier. and I'm looking for a pair that will give me -1. My pair is going to be 6 and 5. So now I'm going to tee off. We don't care about that 2 on the outside because 2 can never equal 0. So I get x equals 6 and I get x equals -5. So I have 2 answers for x, which means this system has 2 points of intersection. But if you remember back at the top, I told you that you need an x comma y. So I need to go back and get a point. I need an x value, a y value for each of my x values. So I'm going to take those 2 x values that I have, x equals 6 and x equals -5, and I'm going to substitute in to find y. I'm going to plug back into one of those original 2 equations. So if I take a look back at my original equations, the top equation is our line, so that one's going to be a little bit easier to plug into. So I'm going to use the x plus y equals 1 equation. So x plus y equals 1, but we already know x is 6. So when I subtract 6 from both sides, I get y equals -5, which means this is really the point x comma y. It's going to be 6 comma -5. So that's 1 point. Now I'm going to repeat the process with that -5, still using the x plus y equals 1. So this time I have -5 plus y equals 1. To solve for y, I'm going to add 5 to both sides, so y equals 6. So my second point of intersection is -5, 6. And there is your answer to the question. Let's take a look at one more example. X plus 1 squared plus y minus 1 squared equals 18. That's my circle, and then my line is y equals x minus 4. In this example, I don't need to solve for x or y because it's already in y equals form. So what I'm going to start by doing is taking this and plugging in. So x plus 1 squared stays. This time, instead of y minus 1 squared, it's going to be x minus 4 minus 1 squared. And that's equal to 18. So x plus 1 squared plus, in this parentheses, I'm going to get x minus 5 squared. So for each of these parentheses, I need to do the box method or double distribute. So I'll draw that out over here on the side as my scrap work. X squared, x, 1. So we get x squared plus 2x plus 1. And then my box method for the next piece, x minus 5 and x minus 5. X squared minus 5x minus 5x and plus 25. So this gives me x squared minus 10x plus 25. So now I'm going to take each of those pieces and put them back over here. My x plus 1 squared was x squared plus 2x plus 1. And my x minus 5 squared was x squared minus 10x plus 25. And this is all equal to 18. So now on the left side, what I want to do is combine like terms. I have x squared plus x squared, which gives me 2x squared. I have 2x minus 10x, which gives me -8x. And I have 1 plus 25, which gives me 26. So once again, I have an x squared equation. I want to set it equal to 0. So I'm going to subtract 18 on both sides, leaving me with 2x squared minus 8x plus 8 equals 0. Once it's set equal to 0, the next thing we need to do is factor. So once again, there's a GCF of 2. So if I take out a 2, I'm left with x squared minus 4x plus 4. And I can continue factoring from here. X and x, minus and minus. My factors of 4 listed out on the side to help me. I'm looking for which pair gives me 4. The answer is 2 and 2. So now I want to tee off. But if you notice, when I tee off, I get the same answer. X equals 2 comes up twice. So that means this time there's only one point of intersection. If I go all the way back to those 3 pictures of my possibilities, it's going to be this middle piece in here because there's only one solution. There's only one x value. So it's going to give me a point that's tangent. So let's go back and just finish out that problem. So I have x equals 2. So remember, when I'm doing this, it's a point of intersection. So my final answer has to be an x comma y. So I know x equals 2. What I don't know is y, and I'm going to plug in to find it. So I go back up to my original equations, and that bottom equation is my linear equation, so this is going to be the easier one to plug into. Y equals x minus 4. So that's the equation I'm going to use. Y equals x minus 4. So y equals 2 minus 4, so y equals negative 2. So my point x comma y is 2, negative 2. And that's the solution to this system of equation.